Determine all the equilibrium solutions to the autonomous dE that we have here. Okay, equilibrium solutions are found how? All you got to do is take out the derivative and replace it with 0. Equilibrium solutions are constant values. So the solution to our differential equation is constant, and therefore the derivative is 0. And so what we need to do is solve for our function n here, having a constant value. So when is this equation equal to 0? When is this equation true? When is the expression on the right equal to 0? And this isn't really a calculus question. This really has nothing to do with derivatives here. The setup, the understanding of what an equilibrium solution is, absolutely does. But at this point, it's just, can you factor a polynomial? Can you find the roots of this thing? The zeros. And we can take out a factor of n. And we'll be left with n squared plus 3n plus 1. And then we might try and do something like the quadratic formula, or we could try to factor. Now, I don't like the 2 there. It's because it's a hard trinomial to factor, but yeah, let's see. 2n, I want to say plus 1, and then n plus 1. Just quickly double check. Yeah, we got 2n squared, the plus 1, and the plus 1 give me 1. And then I've got 1n, and then 2 more n's for 3 n's. There we go. So, oops, I've run out of space, so let's continue this up top. But now that everything's factored, we just say, okay, well, what values of n make each of the factors equal to 0? And so that'll be an n value. I guess it's n of t, but n has a value of 0. Or 2n plus 1 has to be 0, and that would mean n is negative a half. Or the last one, n plus 1 is equal to 0, so that'd be n is negative 1. So 0, negative a half, negative 1 are the equilibrium values, or equilibrium solutions. There we go. All 3 of them.